Let's have a look at this question on probability trees. We've got a coin that's biased. In other words, it won't reflect heads, tails on a 50-50 basis. And the probability of heads is 2/3. Well, immediately from that, what's the probability of throwing a tail? Well, it'll be 1 minus this, which will be 1/3. So we'll use that fact later. The coin is thrown twice, and then we've got to answer some questions about outcomes. Okay, so we've got to complete the probability tree diagram. Given that the probability of a result, heads or tails, is 1, in other words, it's a certainty, we can say that the probability of throwing a tail will be 1/3. Now, when the coin is thrown again, the coin won't have changed. So when we do our second throw, the probability will be exactly the same for both the outcomes, whether the first throw resulted in a head or resulted in a tail. So let's complete the probability tree for the second throw. Okay, let's pop on those probabilities. This is 2/3. This is 1/3. This is 2/3. This is 1/3. So that completes the probability tree diagram, and that should get you 3 marks. Now in part B, we've been asked to find the probability that the coin shows heads both times. So we're going up here, both these branches. What's the probability of reaching our second head? Well, the probability of getting the first head is 2/3. And the probability of repeating that action is again 2/3 of what we've had. The probability of reaching 2 heads is 2/3 of 2/3. So we can say part B. So I can say that the probability of getting head must be equal to 2/3 multiplied by 2/3, which is equal to 4/9. Okay, let's tackle part C and it'll all come clear. Okay, the probability that the coin shows heads at least once. So at least 1 times head. So which paths actually end in that result? At least 1 head. Well, the head-head result works. So does the next result, a head and then a tail. That's at least 1 head, so that works. And then the next result of a tail and then a head, yes, that has a head in it, so it's at least 1 head. The result that doesn't work is tail-tail, so this does not work. So we've got to work out the probability of head-head, head-tail, and tail-head, and then add them up. We've got our first result already, so the probability of head-head equals 4/9. The probability of head-tail, which is our second root here, is 2/3 multiplied by 1/3, which is 2/9. Now the next one, the probability of tail-head, this root in other words, is 1/3 times 2/3, which again will be equal to 2/9. So we add these numbers up and get 4, 6, 8. So we can call this the probability of at least 1 head is equal to 8/9. And that is your answer, for which you would have got 3 marks. So hopefully you can see the general rule that if you go along branches of the diagram, basically going horizontally, you multiply the probabilities. And vertically, the probabilities add.